It was clear from the very beginning that we wanted to be able to recover all the waste heat available and not wasting any of it to the ambient. With relatively minor M&E modifications, we were able to convert the data center to a heat production plant, and simultaneously with the same equipment to be able to provide the cooling for data center. And that's obviously the primary duty of these heat pumps. Ericsson needed more cooling production to the site, since their IT load was going to increase quite rapidly. They also had a relatively old existing cooling equipment that couldn't support the new incoming IT equipment. Ericsson wanted us to find and design an economical and ecological solution for this problem. Fortum wanted us to design a sustainable solution that can provide a constant heating capacity to the local district heating network with reasonable investment cost and payback time.
This cooperation project with Ericsson and Fortum is a bit different because we have here a kind of cooperation model with the cooling system of the data center. In this project, Fortum owns the heat pumps, and we will operate them as part of the cooling system for the data center. I think for the data center operator, this means that they can reduce their investments in the cooling side and focus on their main operations. With heat pumps usage in district heating systems, I think the main thing is the heat sources. So we need to get good heat sources available next to district heating networks, and these can be, for instance, data centers, large buildings with excess heat, even geothermal, waste heat stream from industry, for instance, but the heat sources is the key in this case. In this heat pump project, we selected a new refrigerant for the heat pumps with low global warming potential, because we want to act sustainable way, in a way that helps environment.
In the end, we wanted to design a simple, reliable heat recovery system that can utilize the existing site infrastructure as much as possible, and also enable quick launch of the project. The TCO analysis showed that the proposed solution required the lowest capital expenses and also provided the shortest lead time and payback time for the investment. The solution is sustainable and provides great benefits to the business of both of these companies. It makes the business greener and also reduces the OPEX.
In this project, Mitsubishi Electric has provided two large heat pumps, 1 megawatt of cooling capacity each, to cool down a data center. The heat of the data center is recovered and the temperature is increased up to 70 degrees. This gives a lot of value to the heat. The value is so high that energy company decided to create piping to connect this to a district heating system. And this proves that the return of investment will be very short. Climaveneta is in the IT cooling business since many years. And this project has been interesting to see a new application of chillers or heat pumps into a data center. For a data center owner, the possibility to purchase the cooling direct as a service rather than the full cooling plant, it's a new way of looking at the business. This project shows our commitment for a greener tomorrow.
The benefits of the Climaveneta units on this case is I would say number one reason is to use the environmental friendly HFO cooling refrigerant. The second reason is the reliable partner that we can trust the efficiency values that Mitsubishi Clima-Veneta promised to these units, which delivers the heat to district heating system. And that's measured 24/7. That's the base for the business case what these companies have. If you look at this project, how cool is that? We are bringing two big companies together, which gives benefit for the whole society.
I just wish that more data center companies, at least in the Northern Europe, would see a full-scale heat recovery and cooperation with the energy companies as an option.